Let me show you the easiest way to demo how voltages are shared in both series and parallel circuits. For this, you will need some patch cords, a power supply, 3 bulbs and a voltmeter. So here I'm using a battery eliminator which will give me a safe low voltage at a low current, and I'm using mounted bulbs with these 4mm sockets for easy connection. So before I plug anything in or turn anything on, I just need to take a note of what the max voltage rating is for the components, and these bulbs have a max voltage rating of 6 volts each. So I just need to make sure that whatever configuration that I have and whatever experiment I do, I don't push these beyond 6 volts maximum, and that would just mean that I don't blow any of the bulbs. So with that in mind, let's get set up. We're going to start with a simple series circuit. So if we go from the power supply into bulb 1, and bulb 1 into bulb 2, bulb 2 into bulb 3, and then bulb 3 back to the power supply. That is our series circuit complete. So we've made one continuous loop where the current flows from the power supply through all the bulbs and back to the power supply. I'm going to tidy up these wires so that we can see the circuit a bit easier. Much tidier. So the idea in series circuits is that the voltage is shared between the components, and that sharing will be equal if the resistance of the components is all the same. Now in our case it is, each of these bulbs are exactly the same. So if we have a look at how much voltage we are supplying, we can see that the battery eliminator is set on 12 volts. So this means that each of the bulbs should receive a third of that voltage, so 12 divided by 3 is 4. So if we hook up our voltmeter, we should be able to test whether that is correct. So if we go from one side of the voltmeter into one side of the bulb, and the other side of the voltmeter into the other side of the bulb, so we are connecting it in parallel, we can turn the power supply on, see that all the bulbs illuminate, and then have a look on the voltmeter, and it says that we are reading 4.10 volts, showing that that theory is applied to the practical. We can even cycle through the supply voltage and show that the bulbs decrease in brightness as we decrease the voltage, and we can prove that the bulbs will always receive a third of the supply voltage by measuring with the voltmeter. Let's take this apart and have a look at how parallel circuits work. So for our parallel circuit, we want to get a bulb and connect it across the power supply. So one side of the bulb into one side of the power supply, and the other side of bulb 1 into the other side of the power supply. And that creates our first loop. And then we want to put another bulb in parallel with the first bulb. So we want to go from bulb 2 into one side of bulb 1, and the other side of bulb 2 into the other side of bulb 1. So we've made another loop, and then we want our third bulb again in parallel, so we just do exactly the same. So bulb 3 into bulb 2, and again on the other side, bulb 3 into bulb 2. And that is our parallel circuit complete. So how does voltage work in parallel circuits? Well, we will find out that each of the components will see the full voltage of the power supply, and when we hook up our voltmeter, we can take that measurement. Now this is where we need to be careful, right? Because we remember that the maximum rating on the bulbs is 6 volts, so we need to make sure that we don't exceed that supply voltage to make sure that we don't blow the bulbs. So let's set our battery eliminator to 6 volts, and then we can turn it on. And again, we see that the bulbs are lighting with the same brightness, and each of them should be taking 6 volts from the PSU. Let's take a look. So hooking in the voltmeter in parallel, we want one side going into one side of the bulb, and the other side of the bulb going back to the voltmeter. If I turn it on, we will see 6.2 volts, which is roughly similar to the supply voltage of 6 volts on the battery eliminator. Again, we can cycle through the voltages on the battery eliminator and show that the brightness decreases with supply voltage, and show that each component receives the same supply voltage as we go down. We just need to make sure that we don't exceed that 6 volts maximum, just to make sure that we keep the bulbs nice and safe. So lastly, let's do a combination of series and parallel and see if we can apply what we've learned to that final circuit. Let's take this apart and wire it up. Okay, so for the first loop of this combination circuit, I want 2 bulbs in series with the power supply. So I'm going from the left side of bulb 1 into the negative terminal of the power supply, and then bulb 1 into bulb 2, and then bulb 2 back to the positive side of the power supply. We now want to attach another bulb in parallel, so if I get another lamp and put it here and connect one side to the very left of the other bulbs and the other side to the very right of the other bulbs, that is our circuit complete. So let's have a quick think about what we expect. So we know that the one in parallel should see the full voltage of the power supply. So if we put this up to 6 volts, which is the maximum that the bulb can take, the voltage drop across here should be 6 volts, right? And then on that inner rung where we've got 2 bulbs in parallel, the total there will also be 6 volts, but it will be shared between the 2 bulbs. So each of these bulbs in series should have 3 volts. So let's attach the voltmeter in parallel and see what voltages we're reading. So I'm going for the positive terminal on the voltmeter to the positive side of the bulb, and the negative side of the voltmeter to the negative side of the bulb in parallel. And if we flick the battery eliminator on, we are seeing a voltage drop of 6.2 volts across the bulb in parallel. And then if I pull this out of the parallel bulb and put it into one in series, we will see that the voltage drop that we get now is 3.01 volts. So that theory works perfectly for the practical. Again, as we ramp through the voltages, you can see the brightnesses of the bulbs changing. And it's as simple as that, a really nice, easy way to demonstrate how those voltages are shared in series, parallel, and combination circuits. I really hope this has been useful. Thanks for watching, and I'll see you next time.